Hello everybody and welcome to my presentation. This one has multiple parts in it. For this assignment, I had to do a couple of things, but in the end, we had to make this distance sensor, this ultrasonic distance sensor, interact with some LED lights, and that's going to correspond how far away something is or not. Um, but in order to do that, we had to take this in baby steps, and this is the first step. The very first thing we had to do is use analog right, which is going to basically, um, with analog right, you don't just turn things on and off. They're not just high and low. They're represented by 0 to 255. So zero, and it's a voltage. So zero would mean that it's off or there's no voltage going through it, and 255 would mean that the voltage is high. And typically with the Arduino, it's going to be 5 volts or 3.3 volts. So if you get a number in between, it is going to be between 0 volts and 5 volts. So it could be 2 volts or 3 volts or 1.7 volts. It all has to do with pulse width modulation, which is basically a way to trick a sensor into thinking it's analog. That's the best way I could come up with it. So with pulse width modulation, um, you have a like I would call it like a duty cycle. So it happens fast. So voltage is going to be high for a moment and then low for a moment. Okay, and when you introduce different voltages, you're basically, the way I want to put it is, you're turning it on and off for a different amount of time. The longer something is high, it's going to read closer to 255. The longer that something is lower, if something's lower, it's going to read closer to zero. So if I have a reading of like 100, 125, let's say, it's pretty much right in the middle. So we're going to be running at like 50% power, or it's going to be on half of the time because it's going to, on off, on off, on off type of thing. That's just my basic way of explaining it to you. But getting in the code here, it's really easy. I have a Boolean that's going to basically turn on and off, and I'll show you that in a minute. I have one integer, it's an LED, and I assign it to pin 5. So I use the serial bus to do it, to monitor it, and it works. The pin mode is going to be set to output. So in the loop, it's really simple. If the state equals true, we're going to climb from 0 to 255 in this for loop. And while we're doing that, we're going to write that integer I to analog right and send it to the LED pin, which is 5. So basically it starts at 0 and it climbs up. So what's going to happen with this is, remember, we're using pulse width modulation. So here's what happens with this. We're simulating an analog signal, so the voltage is climbing, which means that the light is going to appear to get brighter. In all actuality, it's just turning on and off faster to the point where it's not turning off anymore. So our eyes are not built to see those happen that fast, so it gives us the illusion that it's getting brighter, but in all actuality, it's just staying on longer. Okay, so now we know that. So we're going to go from 0 to 255, so 0 to 1 basically, on and off. Okay, and then once it reaches the end of that for loop, it jumps out and the state gets flagged to false. And if the state is flagged to false, then we increment it in reverse. I is going to equal 255. And then as long as it is greater than or equal to 0, we're going to decrement or decrement. And the light is going to slowly fade out. And then it basically repeats itself all over again. Now, I don't have this hooked up at the moment, so I can't show you the serial monitor, but we will jump right into the video for this right now. Okay, so here is stage one of the operation. So we have our LED fading in and out. And, you know, I did some experimentation with this. It kind of works here because I'm using an analog right, but I'm only having it go to 255 and then back down to 0. If I did like the true analog to 0 to, like, you know, 1023, it just took too long. Now, if I were to put this on an analog pin, say A5, it would act, it's weird because it would act like high and low. It would get to a certain amount and then switch on, and then once it dropped below a certain amount, it would switch off. So that was kind of cool. So I just kind of stuck this on pin 5, which is, you know, pulse width modulation pin, and it works. So, yeah, boy, look at this mess. Man, you want to talk about a digital hangover. Anyway, on to stage 2. See you in a bit. Okay, on to part 2. So, part 2 was pretty easy as well. I had to use analog read, and I chose a oh boy, here we go. I'm drawing a blank right now. A photoresistor. There you go. I chose a photoresistor to use as my analog device to do this. And what's going to happen is the photoresistor is going to read an analog signal. It's going to read a value of 0 to 1023. And I apologize, I have to point something out. In the last part of the video, um, I had mentioned that I was using a digital write, and I said that I actually used 1023. I didn't. Digital write only goes up to 255. Just to clarify that. So I just want to let you know that I know my stuff. It was just a stupid mistake in communication. That's all. Anyway, getting back to this. So it's pretty easy. You know, when there's enough light on the photosensor, things happen. When there's not enough light on the photosensor, something else happens. So we'll see what happens in a minute. But anyway, for this amount of code, I have an integer. It's the pin for the sensor. It's analog 5 A5, and then I have an integer for a value because we use that value not only to write out to the serial monitor, but we also use that to write to analog write, so you can see the voltage level um, and thus produce the magic that we're going to produce. So I also have an LED pin that is set to analog 0. So the serial begin, you know, we set the pin modes, we set the sensor to input, we set the other pin to output. The loop is simple. The integer value is going to equal analog read, and analog read is going to read from the sensor, which is A5. Then we use a map. Now, what a map does is basically it'll take a set of values and convert it really into a set of other values. So in this one, we use the value, which is going to be getting a numerical value of 0 to 1023. So there's your analog. And then we convert that from 0 to 255. So it does an interpolation and it does the math. And instead of what's going to happen is it's going to read as analog and then it converts it basically to a digital signal, more or less. So what happens is instead of writing to the analog write up to 1023, which it can't do, it writes it from 0 to 255, like I previously mentioned. So that way we can convert it to pulse width modulation, because pulse width modulation goes from 0 to 255, and that's what analog write is pretty much all about. And then we basically print it to the serial port. And that is about it. Oh, whoa, I have a little bit of a delay in here still that I needed to take out. Sorry about that. I kind of rushed this code, but it works good. Okay, so on to the video portion. Thank you very much. Okay, phase 2 of the operation is to use analog read. And what I did is I have a photosensor right here. And once it drops below a certain threshold, it's going to blink on. It's pretty sensitive here right now because my basement's kind of dark and I'm in the basement right now working in my laboratory. So I think. But anyway, check this out. So if we block the light in the photosensor, the light comes on. Oh, see, it's kind of, I've got it really sensitive right now. Pretty cool, huh? So anyway, it works. All right, mission accomplished. Okay, so I got a little bit of a bonus here for us. I wasn't going to do this part, but I decided to do it anyway. So I have a distance sensor. It is an ultrasonic distance sensor. And we're going to use this to basically get the location, the distance of an object. And how we do that, how it works, how this distance sensor works is it sends out a very high frequency, like 40 kilohertz or something like that. So anyway, it's above the threshold of human hearing. Human hearing is, I know this because I'm an audio engineer. So the human ear can hear from 20 hertz to 20,000 hertz or 20 kilohertz. So 40 kilohertz is well above what we can hear. I am not sure about animals though. So it sends out this high pitch noise that we can't hear. And it uses a formula. And what happens is that signal gets bounced off of an object and back into the sensor. So the two little round holes that kind of look like eyes, one of them is basically throwing out the sound, and the other one is receiving the sound. So it's basically an ultrasonic transceiver. It has a part of it sends the sound out, part of it comes back. So you have a transmitter and a receiver. It's basically an ultrasonic transceiver. So and what happens is it uses a formula that will convert that into a number, and that number is going to be used to be able to calculate the distance. And I have it written out for inches and centimeters. And I have a video that accompanies that goes with this that will show you how it works. Here's the caveat of this though. You know, this assignment is all about analog sensors, and you know, writing the code, there's really nothing analog about the code. We're using digital write. You know, we're using you know, some new stuff, echo, you know, pulse in, which is going to basically get a signal at the time if it's high or low, basically. And we use a delay, but we use it in microseconds because if we do it just a regular delay, if we use a regular delay, it's not going to give us an accurate enough reading. With microseconds, remember, the speed of sound is pretty fast. So the amount of distance that this thing can cover isn't the greatest, but it works. So we need it. And in the end, we need to use microseconds in order to get the accurate reading to do that. So knowing that, here is the code. Okay, so obviously, you know, I have a couple integers for the pins. Here's something different. We use a long integer for the duration, for the centimeters and the inches. And the reason why is because of the amount of values that are in this. It's going to be greater than an integer usually, so we use a long. And then we basically, you know, do the serial port, define the pin modes, And in the loop, this is what threw me off. Okay, we digital write the trigger pin to low. Then we wait 5 microseconds, and then we turn that pin on to high. Then we wait 10 microseconds and turn it back on to low. Then we use the echo pin input. We get the duration by using pulse in and checking that with the echo pin set to high. So in other words, this is what's happening. We're bleeping a sound very fast. Okay, boop, boop. Okay, and then we're turning on the echo pin, which is the pin that's going to receive that sound back. And we're using pulse in at the time to see if it's high or low. And with that, we can determine the duration. Okay. Um, Remember, we're turning it on for 5 microseconds and then 10 microseconds. And in between that, we're going to get a duration by that pulse in. And we can convert that using a formula to inches and centimeters. Okay. And that's how this code works. Now here's the video. One thing about this video, when you're looking at the screen, you know, the serial screen, it's tilted to the side by accident. I'm going to try to fix that in post, but if I can't, I apologize ahead of time. Thank you very much. Okay, we have a bonus here. So I got this ultrasonic distance sensor and we got it working. I was having trouble with this because it's technically really, well, it doesn't really run off of an analog pin. So it was tripping me out. Anyway, it works. So it works. I'll show you. So here's the screen. I'm not sure if we can see this, but you'll be able to see that we are doing different things here, and then once I come close, it starts to, yeah, it works. All right, so 2.5 accomplished. Okay, now we're at the final part of our presentation, and this is what this was all about. So we make basically a distance meter, and we use the ultrasonic sensor along with a bunch of LEDs to indicate how far an object is away from the sensor. Really neat stuff here, guys. Let's take a look at it. So, and this is the code I'm going to be submitting to. So basically, here's how I do this. I make two constant integers for the distance sensor, one for the trigger, one for the echo. So the trigger is the one that sends the signal out. The echo is the one that receives the signal. Then I have a bunch of constant integers for the LED lights. I have 8 LED lights that I use, 4 green ones, 3 yellow ones, and 1 red one. And the closer you get, it kind of climbs up a ladder from green to red. So, you know, green is go, yellow is caution, red is don't come any closer, I guess. Then I have integers to calculate the distance of the object. I have duration and distance. And then our setup function, where we set all of our pins to either outputs or inputs. And I really should have just used a loop, a for loop, to do this. I had it in my code for the Larson scanner, which I kind of combined with this, but I changed it. I just wanted to change it up, to be honest with you. I decided to handwrite it out. I guess it's good to do that every once in a while. Then we start the serial monitor here. So here's the loop. The ultrasonic sensor is going to do what it needs to do. We basically digital write to the trig high. We delay in microseconds, 1,000 microseconds, which is basically 1 millisecond. And then we need digital write to trig the low. That gives us enough time to get the measurement. All right, so then we find the duration, and we do that by using pulse in, getting the echo, and setting it to high. Now the distance, this is where the math comes in. We take the duration, divide it by 2, okay? Then we take that and divide that by 2.8.5, okay? And that is going to give us our distance. And that I believe is in, I want to say inches, okay? I want to say inches. You know what? I'm going to double check that. I want to say inches, but if I'm wrong, I'll come back to that. So why am I? I don't know. Why am I confused about that? I shouldn't be. Anyway, it's been a long day. So here's the thing. So this is how this works. If the distance is less than or equal to 7, then we're going to turn it on. Okay, we're going to turn on the first light. Okay. Uh-oh. No. I'm sorry. That's right. I wrote this code in a different way than I was going to. So we turn on the way this is written, and I apologize for this. Is I kind of wrote this backwards. If it starts getting within 7 centimeters, if that's centimeters, I'm sorry, that is centimeters. If it starts getting within 7 centimeters or less, then the red light's going to turn on. And then it kind of goes down. You know, at 14, you got a yellow light, 21, another, 28, another yellow. And then it gets into the green lights. And that's it. It just keeps repeating, and it works. So, yeah, sorry about that. You know, normally I would write this a different way. Normally I would write this, you know, in succession where the green ones light up and stuff like that first. But, no, I did it this way. So, oh yeah, I know why. Because I went from the least amount of distance to the greatest amount of distance, and that was my frame of mind at the time. Okay. Anyway, here it is, guys. The final part. Enjoy.
Hey everybody. Okay, so we are at the final stage of our adventure here. This is the final stage where we build a distance sensor or a distance meter sensor analog. So I have a ultrasonic distance sensor here. Actually, it's not analog though. That's the thing. So I'm just going to have to correct this. Okay, this is not an analog sensor. This is what we were given, but it's not an analog sensor. Now the photoresistor that I had, that's an analog sensor. This one doesn't use analog signals to do what it needs to do, and I'll show you that. Well, I think I showed you that in the code. Anyway, this is the assignment. So I have 8 LED lights. One of them's kind of blinking there because the distance sensor is working. I do have something off in the distance. A series of green, yellow, and red lights, and the closer an object gets to this sensor, the lights are going to start lighting up until the red one, which means don't come any closer. Get off my lawn. Anyway, so here's it in action. Okay, so I have some books here, and I'm going to bring them closer and closer and closer and closer and so yep, the red light's on. Wow, you can't see it, it's all blown out, but they all light up. See? Yes, they do. Works great, actually. So I'm impressed. I'm really happy with this one. So basically I took the Larson scanner that we did and I modified it to work this way. And I'm pretty happy with the results. I actually heavily modified it because it wouldn't work the way I had the Larson scanner set up before. But anyway, it works perfectly. End of the assignment. I think I did a good job. Give me an A. Thank you very much. Have a wonderful day.